Hello everyone and welcome. I want to spend a little bit of time today. First of all, I'll do a little plug to encourage you strongly to make some progress on getting things done. We're down to 9 days in the course, so do keep that in mind. We want to avoid unpleasantness, so please let me know what I can do to help. Moving on. Today I will be revisiting Module 5. The idea is to hopefully set up everyone for success. So that's what I'm attempting to do. So jumping straight in, Module 5 deals with advanced data structures. And our agenda is typical for Module 5 is talk about the reading, Python, and R, and then talk a little bit about the deliverable that's associated with it, in this case deliverable 5. Jumping into what are advanced data structures. In Python, they're basically classes and objects. Inside of R, typically just objects. The deliverable 5 deals with basically applying them, applying the concepts associated with data structures to essentially do some combination of some values, do some plotting as well. So you're basically, the idea is to create a data frame that contains separate columns, then combine them together to form a single data frame that is aligned across the dates. And then to basically create a file from that you can export to R, then take the file inside of R, do some side-by-side comparison, doing some graphing, either ggplot or lattice or something, to draw some pretty pictures, and we'll talk about what that means in the rubric in a little bit. And then calculate some statistical measures, including things like standard deviation, mean, min, max, median, and so on. The Python reading is out of the text that's associated with this course. Feel free to read multiple things out of that O'Reilly resources you have access to. Some really good stuff in there, so take some time, look around in there. You might find something really cool. Inside of R, chapters 8, 9, and 10. Inside of the Python book, it's chapters 4 and 5. Pandas is bigger than a bread box, as we say, so it's something that takes a little while to figure out. So do keep that in mind, that it is a lot of stuff in there, a lot of really useful stuff as well. Classes are a construct inside of Python. Multiple programming languages, Python has their version of a class. A class is a way of encapsulating together data and functions that operate on that data. It has this concept of a self, which is applied or supplied with each of the parameter, or as a parameter for each of the functions that interact with the state essentially of that object, so that you pass it as the first thing whenever you're defining it. You don't actually pass it when you call it because it's handled for you, but under the covers an instance is being created and passed in with your methods calls. So in this case what you've got is a circle, a really complex item here. It has a radius, that is one of its properties. There's the init function is essentially the constructor. It's something that is called whenever the thing is created. Has a parameter of self. That means that it's creating an instance, and it's setting it with the value of R, which defaults to 1. So you can have default values inside of Python that basically say if the user doesn't supply a value, or whoever it is that's calling my constructor, in this case create an instance of circle, if we don't supply 1, then it defaults to 1. You can also see there that there's set radius is a means of adjusting the value of R once it's been set via the constructor. You can also get it and then get the area, which uses the radius and does the pi r squared sort of thing. So that's basically how classes work in Python. Pretty straightforward, pretty basic in a lot of ways, but yet very powerful. And then you can in this assignment, and I'll talk more about this in a moment, the idea is to combine together data frames based upon the date, so that you're aligning them appropriately based upon when the transactions occurred, and I'll show you how to do that here in a moment. This is one way of doing it, basically creating a function to extract the values that we're interested in and call that function multiple times. Again, we'll talk more about that in a moment, but the basic idea is to combine them together in a simple way. You could easily do the same thing, that is essentially that code that's inside of that function call, create slice. You could do that in line for each one of the stocks, but if you find yourself doing the same stuff over and over again, maybe time for a function, and that's what I'm doing here. What you want to do here is merge together multiple data frames, and generally speaking, you want to say how you merge them together. If you're familiar with SQL, there's this concept of an inner join where you're basically saying combine together the two things where a common column matches and exclude those where there's no matching items on either side. There's also variations of that, which is left, right, and outer join, and then a Cartesian product can be created by using a cross join. Cross joins, you may have a way that's where you want to combine together everything in set A with everything that's in set B and all the various enumerations of them so that the number of records that result is the product of the number of records in the first one times the number of records in the second one. So it is literally a Cartesian product. Can be useful if you want to enumerate all combinations. And then on this assignment, a hint, you're going to have more than one data frame, so you need to do them in series. You're going to combine together A and B, which will produce C. You'll take C, combine it with D, and then add in the last one and with another combined to the one you just produced, and you're done. So you've got to chain them together, so to speak. A simple way of seeing some results, and it's always a good idea whenever you're plotting things to see does my graph look anything like the real graph? And you can see here they line up reasonably well. Scale's a little different, but otherwise pretty good, and it also picks up a little closer to the current date. Custom classes in R, you can do it. It's pretty interesting, which means you probably don't want to do it. There is a way of doing it yourself to extend it if you're so inclined. There's a link on the screen there that will take you to how to do that. You most likely don't want to do it, so just say no. Plotting inside of R, and as always with the rubrics, you'll notice that they say go above and beyond. Don't just do the bare minimum, so that means doing things like changing colors, borders, scales, whatever it might be, so aligning things in different ways. You can do this plotting in Jupyter Notebooks as well, as I'm sure you know, and this is showing a simplistic plot. We'll see this in a moment, but it's basically plotting it by the date, and you can see they're lining them up pretty well. So deliverable 5, it does center on advanced data structures. You're to take the 4 stocks that we've talked about, the Google, Apple, Facebook, and Amazon, combine them together based upon the date and then plot it out. That's the basic idea. And you're essentially doing them, aligning them. That's where when you say calculate or plot the stocks side by side so you can see them, is in order to do that you need to have them aligned properly. Your rubric, shoot for the mastery column as always. So breaking that down, use the Python programming language to read GAFA data into Python data frame, append data from Apple, Facebook, and Amazon to the data frame, and then include significantly more error checking logic to determine that the data was read in correctly. Then use Python grouping functions to group them together for analysis, includes significantly more error checking logic to determine if the data was read in correctly. Use the R programming language to read the data into an R data frame, append data from Apple, Facebook, and Amazon to the data frame, and then significantly more error checking. So again, underlying theme there, the differences between a C and an A is, generally speaking, data checking. So make sure, do some inspection, some validation of the stocks, and so are the values to ensure that they're there. The exception, though, is on the next item. Don't just do min and max, include things like min, max, median, skew, standard deviation, mean, and so on. So add some additional aggregate functions there and life will be good. Then use R to graph each of the stocks using the default settings, and then including significantly more options to customize the graphs to make them more visually appealing, so make them look pretty. And with that, we've concluded what we have to say about that. So one moment while I find what I'm looking for. Here we go. So hopefully this is not giving away too much. I don't think it is. I'm going to go ahead and clear my kernel, and so that we're seeing, making sure that you see there's no smoke and mirrors going on. So basically here what I'm doing is loading in the data frame that we've been dealing with. pulling in pandas to do so. So I'm basically constructing the file name and then loading it into the data frame. Then I'm calculating the average based upon the open and the close. Then this is the function that I talked about earlier that creates a slice. It takes in a stock name, a friendly name, and an input data frame, and it returns back sorry, I held down a key too long. Returns back a data frame that is essentially the one that we're interested in. And we use that to set them to these appropriate data frames for each one. This is that split, merge, combine sort of thing that we've talked about before. And you can see here's what the Google frame looks like. This particular merge, I'm not being overly clever. I'm just merging together Facebook and Google together and putting the output here to a data frame. You'll notice that I didn't make the data an index. Probably should have, but it doesn't really hurt because we're specifying what we're joining on or merging on. Then I do the same thing again with a merge. So I'm taking my frame that I created up here, this DFX, and I'm adding to it Apple basically, and I'm still joining again with an inner join, essentially, or an inner merge on date, and it produces. I'll redo that because I inadvertently ran it twice. So let's go ahead and redo that so that we don't have two apples. On this line, did the same thing again with Amazon. So you take it, you can stick two of them together, Facebook and Google. Then you need to add the third one, which is Apple. Then add the fourth one, which is Amazon. All of them aligned on date. And you can see here the dates, and each one of them have stocks. There's nothing that doesn't have a value. Then what you're doing on this course, you need to, or for this assignment, you want to save that out so you can pick it up inside of Python or in R. And then here I'm basically showing just a simple plot of showing it. Here's an interesting sort of thing you can do is you can specify the
top search result.
Index. Google Home was listening. You can set the index to be the date, so it shifts it over here from an artificial date to a real date. This should probably plot a little better now, though it looks like it did the same thing. I was hoping it would actually honor that. Maybe it didn't. I didn't save it, but I need to save it. Let's see. So what did I do? Yeah. So let's say this is that. So I'm setting the index to be the date column, and you can see here now it is the date. So if I plot this again, I should actually see dates on the bottom instead of just numbers. So probably should have done that the first time through. Setting the index is a pretty useful thing, can simplify stuff. Probably could simplify this join up here, or this merge up here. If they both are indexed on the same thing, probably don't have to say what you're indexing on. Haven't tried it, but probably not. So here's where we're doing some of the aggregation. I'm running a group by on the date column, and I'm saying give me the mean, max, and standard deviation. If you take a look at what that looks like beforehand, it's a kind of a stacked column thing. So you've got Facebook, and then I've got the three things that go with it. That might be what you want, or you may want to have the names so you can actually see them. This magic code basically says produce a set off of the product of joining together the results of the column names, and set those to be the names of the columns. So basically what we're doing is taking these column names, and I'm going to insert another cell so you can see it. And you can see here it's Facebook mean, Google, Facebook max, and so on. Strip join them together, and basically what you end up with is a data frame that's definitely a lot more appealing and potentially useful if you're going to do something more interesting with it later on. So a handy thing to keep in mind and to use so that you're familiar with it. So that in a nutshell is the Python side of this deliverable. And with that, I'm going to go ahead and wrap this up. As always, if you have any questions, let me know. That's what I'm here for. And we are getting to that last week of class, so now's the time. Dig deep, finish strong, and if I can help you, give me some time to be able to help you. So don't wait to the very last day and expect to be able to knock out 5 or 6 deliverables. It's not going to necessarily be feasible. So with that, stay safe, and I will speak with you next week.